All right, we are going to be looking at reactions in aqueous solutions, specifically double replacement reactions in this video. And a double replacement reaction happens when ions exchange between two compounds. So as you can see here, A is bonded to X, B is bonded to Y, the X and the Y switch, or as you could say the A and the B switch, and you get two new compounds in the product. So here the hydroxide and the chloride switched what they were attached to. A lot of times you're going to get what's called a precipitate in these types of reactions, and we've talked about precipitates before. They're the solids that are produced during a chemical reaction in a solution or aqueously, like what we've been looking at. So we're going to be going through the steps to determine what are the products of these reactions and how we know which one, if any, of the products are the precipitate. Okay, so let's go through the steps for predicting the products of a double replacement reaction. We're going to work through an example together, and our example says aqueous solutions of barium nitrate and aluminum sulfate react to form a precipitate. So in the end, we're going to know what the precipitate is. We're going to have a balanced equation to show the chemical reaction that makes that specific precipitate. So the first thing we want to do is we want to figure out what are our reactants. So barium nitrate and aluminum sulfate. We need to figure out what those formulas are so we can write them in our balanced equation. So you're going to need your periodic table. If you don't already have it out, go ahead and get it out. And we're going to take a look at the charges of the ions and put them together to make compounds. So look at your periodic table. The charge of a barium ion will be +2. We all know nitrate, NO3 minus 1. When they bond together, we get BaNO3 2. Okay, and then we look at the other reactant, aluminum sulfate. Aluminum, look at your periodic table, has a charge of +3. Sulfate is one of our polyatomic ions that we all have memorized, SO4 -2. For them to bond with each other, we would have to have 2 aluminums and 3 sulfates to make Al2SO4 3. All right, so those are our reactants. Now we can go through the process of the double replacement. So our next step that we're going to follow to figure out what our ions are. We kind of just already did that. And the reason we need the ions, we have to break them apart so they can replace each other and then bond back together. So if we look at what we just had, we want to list out our ions again. Ba was a +2, nitrate -1, aluminum +3, and sulfate -2. So now this is going to help us figure out which things replace each other and what is going to bond with what to make our two new products. So when we do our double replacement, you can replace the cations, you can replace the anions, but remember you always have to have a cation bonding to an anion. You can't put two pluses together, you can't put two minuses together. So let's take a look at our next step, which is to replace the cations and make the products. Okay, so our cations are barium and aluminum, so they're going to switch with each other, which means the barium will now bond with the sulfate, and they both have +2 -2, so one product is BaSO4. And then the aluminum will bond with the nitrate. Now, cations always go first, so the aluminum is written first. We're going to need 3 nitrates, so AlNO3 3. All right, those are our two products. And now that we know what our products are, we can figure out which one will be the precipitate. Okay, so to do this, you're going to need your solubility rules, and that should be the very last page of your notes. They're called solubility of common ionic compounds in water. And the way the solubility rules work is this top part tells you things that are soluble and what their exceptions are. And then the bottom part tells you things that are insoluble and what their exceptions are. Soluble things, those are the aqueous things. Insoluble things, those are the solid precipitates. Okay? An exception down here would make something that's normally soluble insoluble. So if it's one of these with an exception, then it becomes the precipitate. So we're going to be using this to figure out which of our two products is the precipitate. Okay, so let's start with barium sulfate. So looking at our solubility rules, let's find sulfate right here. Normally sulfate is soluble, except when it's bonded to strontium, barium, lead, and mercury. So barium bonded to sulfate now becomes insoluble. So if we come back over here, we know that this barium sulfate will be our precipitate. Now let's look at the other one, aluminum nitrate. This says nitrates are soluble, there are no exceptions. So anything with nitrate will be aqueous. So what we can do is we can now fill in our states. So barium sulfate we decided was our precipitate, and precipitates are solids. Aluminum nitrate is soluble, which is aqueous, so it gets the AQ. Now we know that this is the precipitate. Okay, so we just figured out which product is the precipitate. Okay, our last step we have is to balance our equation. So we want to come down here. This is the equation that we have just figured out, and we want to balance that equation. So if we take a look at our subscripts, we're going to have 2 nitrates here, we have 3 nitrates here. We're going to have to make a grand total of 6 nitrates. So we'll put a 3 in front, we'll put a 2 in front. That makes the aluminums balanced. It makes a 3 here, and then everything should be balanced. Okay. Alright, so let's take a look a little closer at these aqueous solutions, these things that have AQ on them. An aqueous solution contains one or more dissolved substances in water, and the things that are dissolved in water are called solutes. So generally, you know, the ionic compounds that are aqueous, those are the solutes. And then the solvent is the most plentiful substance in a solution. That's going to be water in an aqueous solution. That's what the term aqueous means, is water, dissolved in water. All right, now our possible solutes, the possible things that could be in solution, are molecular compounds, and they exist as whole molecules. They could be compounds that produce hydrogen ions, and we call those acids, or they could be ionic compounds that dissolve in water, and their ions separate in a process called dissociation. Now, if you take a look here, you can see the difference. NaCl is ionic. When it dissolves, the ions break apart. Sodium ions, chloride ions. Sugar is a molecular compound. So when sugar dissolves, the entire sugar molecule stays together. It just separates from the other sugar molecules. So in an ionic compound, we have cations and anions. In a molecular compound solution, we have whole molecules. Okay, when two solutions that contain ions as solutes are combined, the ions might react. If they react, it's always a double replacement reaction, where we can get either a solid precipitate, water, or a gas. And we've seen how we can get a solid precipitate. So what we're going to look at next is how to kind of focus on what that product is that we're getting. And to do that, we need to take our balanced equation that we got, and we need to write what's called a complete ionic equation. And a complete ionic equation shows all the particles in a solution as they actually exist, meaning aqueous ionic compounds split up into ions. Solids stay together as whole units. So if we have this balanced equation here, okay, we need to show the things that are aqueous into ions. Things that are aqueous break apart into ions. The things that are solid stay together as solids. So we took all 3 of the aqueous components and we broke them apart into their individual ions, which is what aqueous things really are. So that's called a complete ionic equation. Now, what we want to end up with is called a net ionic equation, and that basically shows the just the particles that participated in a chemical reaction. So it takes out what we call spectator ions. And spectator ions, just like it sounds, they're, like fans in the stands, they're spectators. They don't participate in the chemical reaction. They're there, they're in the solution, but they don't actually do anything. They started out aqueous, they end up aqueous, they didn't bond. So they don't really participate, they just spectate what's happening in that chemical equation. Okay, for example, we have sodium hydroxide, copper, and chloride ions all on the reactant side. When the copper and the sodium replaced each other and we made copper hydroxide, that became the precipitate. The sodium and the chloride stayed aqueous. Our aqueous is down here. It goes over here. So what we can see is the sodium, the sodium and the chloride ions, they didn't actually participate in the reaction. They are spectator ions. So here and here, they stayed the same. It's still sodium and still chloride. Those are going to be our spectator ions. So the hydroxide and the copper are the ones that bonded together to make the precipitate. Okay, so you can see that we have two ions that are spectator ions. All right. So to write a net ionic equation, we're going to end up taking those out. Okay, now there are going to be some reactions that produce water molecules, which means you don't really see anything happening. You don't see a solid being produced because you can't really see water being made in water. But what you end up with are the hydrogen and hydroxide ions making the water molecules. So you're not really going to observe anything, even though there is technically a chemical reaction happening. So we're going to pause right there. In the next video, we're going to go through a couple of examples of writing net ionic equations.